Alright, so in today's video we're going to go over the two types of alkene addition reactions that have non-stereoselective stereochemistry. So the two types that we've learned are hydrohalogenation, so it can either add HBr, HCl, or HI. So that's our first type. Or we can have acid catalyzed, which can either be written as H3O+ as our reagent or H2O, H2SO4. Okay, so to figure out why these two are non-stereospecific, we first have to draw our mechanisms. So I'm going to quickly just draw these out. Okay, so let's do HBr for this one. So here, we're going to have our nucleophile, which is our pi bond, and it's going to go and attack our hydrogen. And then we're going to form bromine minus. So we can draw our hydrogen here, and we are going to end up having a carbocation, and the electrons on bromine, like this. Okay. So now, the bromine goes and attacks our carbocation, and our final product looks like this. Okay. So that's quickly drawing it out. We'll talk about the stereochem in a minute after we finish out drawing both of them. So then we could do H3O+ also. So again, same thing happens where our nucleophile or our pi bond comes and grabs our hydrogen, and we generate H2O, and we form a carbocation. So then we'll also draw our H2O right here. Now our H2O is going to go and attack this carbon. And we have OH2. Let's actually draw it like that so we can clearly see our hydrogens. And H2O has a positive charge. We'll have some base come and deprotonate so that our final step leaves us with just OH. Okay, so now let's actually look at these two and figure out what's the similarity between them. So the only the most important similarity is actually the fact that we're forming a carbocation for each of these. So this is actually the reason that we have all four potential stereoisomers, is because this bromine here can attack on, let's think of this carbocation as a p orbital. It can attack on this side, or it could also attack on this side. And the hydrogen also could be placed here or here, right? Coming from either direction. So because of that carbocation, that's what makes it so that it's non-stereoselective, is because the nucleophile can attack from either direction. So if we were to write out all the possible products, let's just do it for one of them. Let's do it for this one right here, this reaction. So we could have both coming towards us, H and OH coming towards us. We could have H and OH going away from us. We could have hydrogen coming towards us and OH going away. Or we could have hydrogen going away and OH coming towards us. So this is technically what all the products would look like for this reaction.